Assalamualaikum warahmatullahi wabarakatuh. My name is ANJEL NURMAULIA. I'm a student of the State Islamic University of Sultan Syarif Qasim Riau. In this video, I would like to explain about continuous random variable. Well, what is continuous random variable? Continuous random variable is a random variable where the data can take infinitely many values. For example, a random variable measuring the time taken for something to be done is continuous since there are an infinite number of possible times that can be taken. Well, in this occasion, I wanna focus on 5 parts of a continuous random variables. The first part is motivating example. The second is basic concepts. The third is elementary examples. The fourth is normal distributions. And the last is normal sampling distributions. Well, for the first is a motivating example. In this section, we illustrate some of these difficulties by considering a random variable x whose set of possible values is the unit interval. For example, x is equals of 0.1. Specifically, we ask the following question: what probability distribution formalizes the notion of equally likely outcomes in the unit interval 0.1? Likely, then the probability of each subinterval equals the proportion of the entire interval occupied by the subinterval. To construct a probability distribution for these situations, it is necessary to assign probabilities to intervals, not just to individual points. And the probability distribution that we have constructed is called the continuous uniform distribution on the interval of 0.1, denoted uniform of 0.1. If x uniform of 0.1, then the CDF of x is easily computed. And you can look at this. For the first, if y less than 0, then fy equals px less than or equals of y equals px x element minus infinity point of y equals 0. And then if y is element of 0.1, then fy equals px less than or equals of y equals px x element minus infinity point 0 plus px x element of 0 point of y equals 0 plus y minus 0 equals y. And then if y rather than 1, then fy equals px less than or equals of y equals px x element minus infinity point 0 plus px x element of 0.1 plus px x element of 1 point y equals 0 plus 1 minus 0 plus 0 and equals 1. And the second is basic concepts. Consider the graph of a function f r as depicted in figure 4.3. Our interest is in the area of the shaded region. This region is bounded by the graph of f, the horizontal axis, and vertical lines at the specific endpoints at A and B. For a very view function, such as the one divided in 4.3, it is possible to determine area A, B, and F by elementary geometric calculations. And we now introduce an alternative to the probability mass function. For the first definition is a probability density function is a function f r such that first is fx less than or equals of 0 for every x element r. The second is area minus infinity point infinity of f equals infinity minus infinity fx dx equals 1. And the second is definition of a random variable x is continuous if there exists a probability density function f such that p x element of a point b equals ab fx dx. So for discrete and continuous random variables, the expected value is the PMF or PDF weighted average of the possible values, and the variance is the PMF or PDF weighted average of the square deviations of the possible values from the expected value. Because calculus is required to compute the expected value and variance of most continuous random variables, our interest in this concept lies in understanding what information they convey. And the third is elementary examples. In this section, we consider some examples of continuous random variables for which probabilities can be calculated without resort to calculus. I have an example. What is the probability that a battery-powered wristwatch will stop with its minutes hand positioned between 10 and 20 minutes past the hours? To answer this question, let x denote the number of minutes past the hour to which the minute hand points when the watch stops. Then, the possible values of x are x is equals of 0.60, and it is reasonable to assume that each value is equally likely. We must compute px element at 10.20 because this value could be 1/6 of the possible values. It should be obvious that the answer is going to be 1 or 6. To obtain the answer using the formal method of probability, we require a generalization of the uniform of 0.1 distribution that we studied in section 4.1. So, to notice the analogy between the PDFs, the present PDF defines the continuous uniform distribution on the interval of 0.60. Thus, we describe the present situation by writing x uniform of 0.60. To calculate the specific probability, we must determine the area of the shaded region in figure 4.4. For example, px element of 10.20 equals area 10.20 of equals 20 minus 10, 1, or 60 equals 1 or 6. And the fourth is normal distributions. Normal distributions is one type of distribution with a continuous random variable. In normal distribution, there is a curve or graph which is described as resembling a bell. The normal distribution is also known as a Gaussian distribution. One of the equations contained in the normal distribution is related to the density function. The following is the density function in the normal distribution. You can look at the slide of my videos of normal distribution formula, and for the first a constant with the value 3.14159, exponential number with a value of 2.7183, average mean of the data, standard deviation of normally distributed data, and how to calculate z value. The z value can be calculated by the following formula: z equals x minus a constant or standard deviations. And also, we will not make extensive use of 4.7. A great many useful properties of normal distributions can be deduced directly from it. Most of the following properties can be discussed in figure 4.7, and you can look at this on my videos. And the next, the standard normal distribution is normal 0.1. The following result is on enormous practical value. If x normal average point standard deviation 2, then z equals x minus average or standard deviation normal 0.1. And the last is normal sampling distributions. This section collects some definitions of and facts about several important sampling distributions. It is not important to read this section until you encounter this distribution and later chapters. However, it is convenient to collect this material in one easy-to-find place. Suppose that Z1 and Zn normal 0.1, and consider the continuous random variable y equals Z21 plus plus Z2 or n. The distribution of y belongs to a family of probability distributions called the chi-squared family. This family is indexed by a single real-valued parameter v is element of 1 point infinity, called the degrees of a freedom parameter. We will denote a chi-squared distribution with v degrees of freedom by x to v. F distributions finally let y1, x2, v1 and y2, x2, v2 be independent random variables and consider the continuous random variables. F equals y1 or v1 or y2 or v2, and then the probability density functions of v1 point v2 for v equals 2.12 4.20, 9.10. Well, I think that's all from me about continuous random variables. I'm so sorry for my mistake. Thank you for watching this video. Wassalamualaikum warahmatullahi wabarakatuh.